All right, well, let's finish off the week of this standard that we've been working on this week just with a ReadWorks text called about refraction, okay? So remember, we were looking at the properties of light. Just a quick review, we learned how white light is made up of all the colors of the rainbow. You can shine white light through a prism to break it up into Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. We looked at how light can be reflected. It bounces off objects. Light can be refracted, which is what we're going to focus on again today, how it's bent, and how light can be absorbed like a sponge absorbs water. And that absorption of light turns it into heat energy. I told you my story about burning my feet and my legs on a hot black truck. We looked yesterday at how objects can allow light to pass all the way through, and they're transparent. Some objects scatter light as it passes through. They're translucent. Some objects block light. They're opaque. So we've learned a lot about light this week, and we've also learned kind of what the standard is talking about. The bending as refraction, it determines what we see, the colors available. We've also learned that we see colors of an object. So if you're looking at something that's red, like an apple, we see this apple as red. That's a big apple. It's not real, because this apple is absorbing all of the colors of the rainbow except for red, and it is reflecting red light. That's why it looks red to us. So that is some of the things we've talked about this week. Like I said, excuse me, we're going to kind of go back and focus on refraction one more time today. So you've got a couple, myself right in the way, got a couple of little slides. Just want to remind you of how light can be refracted through a prism. This little experiment video shows you how you could do that if you had a prism. Then you've got just a real short, like 4-minute Bill Nye video showing you the colors of the rainbow again and talking about refraction. And then we've got this text today that we're going to read together from ReadWorks. It's a pretty short passage. You can't play this, sorry. If you were on the ReadWorks website, you could listen to it. But not on these slides. You're going to listen to it anyway because I'm going to read it to you. So let's take a look at this passage called Refracting Light. It's very simple. You'll have 4 questions again today from this text. All right, so here we go. The speed of light is very, very fast. However, the speed of light can change. Take a straw and put it in a glass of water. Now look at the straw where it enters the water. Can you see that it appears to be at a different angle? That is called refraction. It's caused by the slowing down of light as it moves from air to water. As the light enters the water, it changes angle direction because it slows down. It seems like magic, but it's really just how light travels. No trick. Well, here's a picture of that straw in the water. So it's going, and it looks like the water cut it in half there, doesn't it? But that is not a trick, as it said. That is refraction. The light shining on the straw slowed down, so it changed how we see things. The bending of the light there, it changed it, makes it look bent. Okay? You may be surprised to learn that there are many ways we use light refraction every day. Do you or any of your classmates wear eyeglasses? I've got some right here. I usually read them when I wear them when I'm reading, but these words are kind of big on my screen, so I don't really need them. The lenses in eyeglasses correct different kinds of vision problems by refracting light. Transparent glass, obviously the lenses of glasses are transparent. You have to be able to see through them, right? Or plastic lenses are made to refract light in different ways. So when I put these on, when I'm looking at the screen right now, those words are okay. I can see them, but they're not clear. But when I put these things on, they are clear. It's just like clear as day. Why is that? Because the lenses in my eyes are not working correctly to see things far away. And so these glasses refract that light. They bend it, and the eye doctor knows how that direction they should bend it in so that I can see better. Like mirrors, these lenses can be convex lenses or concave lenses. Mirrors and lenses that are concave or convex have curved surfaces. So you see the little boy in the picture there? And you see my glasses here. They are lenses that do what we're talking about. They refract light. They bend the light to help us see better. And we talked last week in ELA about using a dictionary. If you were to look up refract in a dictionary, might see this. It's a verb. It's to do something. Okay. It's an action. The definition is to bend, rays or waves of light, heat, sound, or the like, in passing them obliquely from one medium into another, which transmits them at a different speed. That's a fancy definition, isn't it? We know it's waves of light that are bent because they went from air into water. That's what it's talking about. The rays of light are refracted by the prism. Now, what would change about, how could these glasses change the light? Well, they're a lens, so the light's coming from the air and hitting that lens. And that's what's causing the refraction, because they're coming through a lens or a piece of glass that's curved to direct the light a certain direction as it's refracted. So forms of the word refract would be refracted, refracting, and refracts. All right. Now, don't be surprised if one of your questions comes from this definition page right here, okay? So I'll let you watch the rest of the videos on the slide and get to your question set. Have a great weekend.